Alright guys, we're back. Sorry I did not post it today. It was a pretty long day. What is today? Day 17. This is going to be day 18. Thank you for your comments, guys. Really appreciate it. I'm making a cool Discord for people. As besides the points, just want to get day 18 out, even though this is day late. And make sure the streak stays alive. I'm going to be going back to school this week, so the videos will definitely be shorter as I'm packing stuff, but whatever. And we are currently second leaderboard. This guy Kobe is absolutely mocking us. He's already done with DSA and with the stack size around. But it is what it is. You know, I'm going to race myself, not anybody else, so that's the most important thing. Let's get back on grind. So a depth first search. Depth first search is another algorithm. Traverse a kind of like breadth. Traverse a graph kind of like breadth first search. Traverse a root node as far as possible before backtracking and starting our next branch. So it's like can I just use circles and arrows since I can't draw? Just way. So it's like you go down one end all the way down before you go back to the top and go down another end like this. Unlike breadth first search, which is like breadth first search goes like this, and then like this, then like this. Obviously it's a rough sketch, but you get what I'm saying. Yeah, go all the way down before going down the other path, Z and C. Watch things if you guys want to add depth first search feature. Alright, search get the depth first search R. Depth first R is recursive helper method. Depth first search takes a start vertex as input and traverses the graph in a depth first manner. Order vertices if it's on list. Okay, so let's create a visited list. It's empty. And call depth first search R with the empty list and start vertex. And return we need a store where this recursive thing is returning inside this variable. Okay, it visits the current vertex by adding it to a list. So visited dot append the current vertex. Get a sort list of neighbors of the current vertex. So sorted self dot graph. The graph is going to have everything that its vertex is connected to. So that would be its neighbors. I'm going to call that neighbors. Now I'm starting. For each of those neighbors, for neighbor and neighbors. If the neighboring vertex is not in visited, visit it by recursively calling depth first search R with the neighboring vertex on visited with the neighbor. So when is this thing gonna stop? what does it return? Guess the neighbors list is empty. We return. Let me just run and see what happens. Oh, self. Because this is a class. None type is not iterable. I think he's talking about right here. If neighbors is none, return visited. None type is not iterable. Assuming this is happening before loop, but I'm literally say it's not iterable. They mean you can't loop, right? I'm almost positive what iterable means. Let's double check. Yeah. So if neighbors is none, return. Or maybe it's the, oh, maybe it's this that's the error. Yeah, this is what I don't like about this. It's like it's giving me an error, but I don't know what line it's happening on. So how am I supposed to know what's actually going on here? It's kind of annoying. No, this is where it's happening. Okay, so I just don't know what this is supposed to return. And we're not really doing anything. I think we are supposed to return this at least, because we need to do something with the list it has. Kind of stuck here. I think it's happening before the for loop is run with an empty neighbors variable being used. I tried to check for it and return, but it didn't change anything. It's coming from the recursive call. None. Oh. Return visited. Yeah, that's not good. If we return immediately, then we're not allowing. Saying this isn't needed. Yeah, if the list is empty, it's not going to loop. That's what I was thinking before. So, okay, yeah. Why did I make all these dumb mistakes, man? Okay, so what happened here? We shouldn't return as the first thing in a list. Damn it. I deleted that. I should not have deleted that. You know what? I'm just gonna do this in Notion. Maybe I'll move it later, but so what were we doing? We're doing this. I don't know if I really need the code. Do I? Returning before immediately after the first iteration prevents the rest of the loop from running. Return something from the function if you don't want to return none. And then yeah, this check is unnecessary because if the neighbors list is empty, the for loop will not run by default. Okay. So yeah, I'm just trying to take notes, because if I'm going to look at, I feel like looking at solutions isn't bad if I'm not like just look at a solution for the sake of looking at the solution. If I'm understanding why the solution works and why what I was doing didn't work. Kind of base it off of kind of based off of this right here. Actually, this is from a Nico video, but this is Scott Wu. He's now the CEO of Cognition, a very smart individual, and he's answering this question. He says, "Hello there, Scott. What's the appropriate amount of time someone should spend on a problem before giving it up and doing it all by themselves? The tutorial instead had asked many about this. Some said 15 to 20 minutes max. Some said a while. What's your take on it? What would be your advice on it? Thank you in advance." It's an interesting one. It seems like a lot of people recommend waiting and thinking more, but I personally look at editorials as soon as I get stuck. Key piece though is to make sure to connect to motivation and solution. How can I make that insight that leads to discovering a solution? A separate question from what is the solution. It's important to think about the former as well. See, I always found this a pretty interesting take because Scott Wu is a very intelligent individual, and he says he looks at solutions in his own words as soon as he gets stuck, and then tries to understand the solution why. See, it's kind of methodology I take. I feel like a lot of times in coding, I just don't solve things if I don't really have the intuition about it. Not that I don't try, like you saw in this video, I tried for a little bit, but try to understand a problem a little bit, try and work at it. If I can't figure it out, if there is a solution available, I look at the solution and try and understand it. Just move on. I don't know. It's a weird concept, but yeah, it's something I feel I probably could have figured out. I think I had the right idea in the first place, but I just didn't act upon it. I don't know. I'm just trying to do things that make sure that I actually stay consistent. Because if I end up quitting because I get frustrated, then all my progress is lost. So if I have to look at solutions all day to keep me coding, I don't see why that's a problem. But I don't know. I really don't know what I'm doing. I'm just going. Alright, that's gonna be the end of this video. Thank you guys for watching. I will see you guys in the next video. Keep on grinding, keep on moving. I guess I don't have to do this. Why do I not have to do that? Oh, because it's already returning visited. Yeah, it's already returned the visit variable, so it's already editing it. Okay. Let's take note of that. Oh, come on, where's a code block? I gotta make a code block. Ah, start it, man. Don't need to set visited here because the recursive helper is already returning it. Alright, that's it. I will see you guys in the next video.